in. Hydrogen fuel cell cars represent a monumental leap forward in sustainable transportation, offering the very real potential to complete.
A hydrogen fuel cell car is an electric vehicle powered by a fuel cell, not a combustion engine. A continuous flow of hydrogen and oxygen react within the fuel cell stack, generating clean electricity. The only byproduct is pure water vapor.
The FCEV driving feel resembles that of an EV. You get instant torque and quiet operation without any engine vibration.
The key promise of hydrogen is here. Fast refueling like gasoline, combined with the clean power of electric driving.
This high-pressure fueling system is engineered for both speed and safety.
Hydrogen fuel cell vehicles aim to solve long EV charging waits, refueling in just minutes if stations are available.
Hydrogen needs high pressure and strong, lightweight tanks. Utilizing advanced carbon fiber composites, the tank materials are expensive, significantly influencing the vehicle's final cost.
Where hydrogen comes from determines how clean FCEVs really are.
Clean hydrogen requires renewable electricity and electrolysis. Harnessing renewable energy is the key, because with hydrogen fuel cell technology, clean input guarantees clean outcomes. To create clean fuel, we use electricity to split water in a process called electrolysis, separating it into pure hydrogen and oxygen.
Hydrogen must be produced, transported, stored, and dispensed reliably.
Despite the promise of hydrogen, the reality is that limited fueling stations remain one of the biggest barriers to replacing internal combustion engines.
When we compare the two, time convenience clearly favors the hydrogen fuel cell vehicle, especially as the supply stabilizes.
Electricity to hydrogen to fuel cell loses more energy than charging a battery EV.
FCEVs still use a battery buffer, making them hybrid-like internally but fully electric at the wheels.
Through regenerative braking, FCEVs capture energy while slowing, significantly improving real-world efficiency.
Long range and steady performance are key reasons why FCEVs are emerging as the leading replacement for internal combustion engines.
Cold impacts all vehicles, but FCEVs avoid some battery range drop by refueling quickly.
This water vapor is a normal tailpipe story, but upstream emissions depend on the hydrogen source.
Longevity matters. Fuel cells must remain reliable for years to compete with proven internal combustion engines.
Fuel cell electric vehicles can be simpler than internal combustion cars in terms of moving parts, but the systems require specialized maintenance.
Safety training is essential for technicians working on hydrogen fuel cell cars.
Hydrogen will likely scale first in heavy transport, and only then influence passenger cars.
Fuel cell cars can feel like the best of both worlds. Electric driving with fast refueling, but only if clean hydrogen and stations become as common as gasoline. It's a network effect. FCEVs need enough stations to be truly convenient, and those stations need enough FCEVs on the road to be profitable.
Behind this pump is a complex system of compressors and cooling technology, all governed by advanced safety protocols to handle the hydrogen fuel.
Hydrogen is safe when managed correctly, but it requires careful engineering and strict procedures.
Many people still confuse hydrogen fuel cell cars with hydrogen combustion engines. FCEVs generate electricity electrochemically, not by burning hydrogen. The fuel cell design is remarkably clean, with far fewer hot, oily parts than a traditional gasoline engine.
When considering stack materials, tanks, stations, and hydrogen prices, it becomes clear that cost is the hardest barrier.
The real advantage over electric vehicles is the rhythm of long-distance travel. A brief stop to refuel.
FCEVs trade charging time concerns for station availability concerns.
Battery EVs leverage existing electricity grids more directly than hydrogen fuel cell cars.
As you can see, the path to batteries is far more efficient than hydrogen fuel cells. This efficiency is why it dominates long-term adoption.
Households with home charging may favor EVs, while apartment dwellers could benefit from fast refuel hydrogen if stations expand.
Hydrogen fuel cost stability will heavily influence whether FCEVs can replace ICE at scale.
The refinement of FCEVs makes them quiet and smooth, competing directly with the best electric driving experiences available today. Hydrogen fuel cell electric vehicles are poised for rapid growth, starting with centralized fleets like taxis, delivery services, and public transport.
Fleet depots reduce the chicken and egg problem by guaranteeing demand for hydrogen.
Hydrogen's strength is storing large amounts of renewable energy over time, something batteries struggle with.
Renewables can make hydrogen. Hydrogen can power cars. But the chain must be economical.
This is the true symbol of the hydrogen vehicle. Clean water, the only emission from the tailpipe. Many regions may choose different solutions. EVs in cities, hydrogen on long corridors, hybrids in transition.
Internal combustion engines dominate because fuel is everywhere. FCEVs must match that convenience to replace them.
Long-term adoption often depends on government support for infrastructure build-out.
Replacing traditional fuel sources means building a new network entirely. Thousands of hydrogen stations will be needed across the country.
FCEVs fit the clean, quiet future city vision, if the upstream supply is truly clean.
Material constraints are the primary hurdle. The reliance on platinum catalysts and specialized membranes significantly drives up
Sayers, hydrogen fuel cell cars can replace internal combustion engines in specific niches first. Long range, fast refuel, fleet. The future is a portfolio. It's about utilizing different technologies for different driving realities.
Some regions may use hydrogen to relieve grid peaks by shifting energy into stored fuel. Refuel fast. Drive electric. Repeat. It's that simple and utterly reliable. Mass adoption requires standardization, mass manufacturing, and stable supply chains for the tanks and stacks.
Apartment charging is hard, but hydrogen stations could offer a public refuel alternative.
Our engineering protections, including specialized valves, sensors, and dedicated venting paths, are designed to manage hydrogen safely.
Real-world robustness means stations, tanks, and fuel cells must perform flawlessly across all weather conditions and seasons.
The long-term replacement of internal combustion engines depends on the full life cycle, production, transport, and the sources of electricity.
Today's hydrogen is often fossil-based, but green hydrogen is the goal. Breakthroughs in cheap renewables and electrolyzers could shift hydrogen economics dramatically.
Consumer success depends on simple ownership, easy fueling, stable costs, and reliable service.
FCEVs could feel familiar to gasoline drivers if stations are widespread.
Hydrogen fuel cell technology competes in a crowded transition landscape, facing rivals like EVs, hybrids, and e-fuels. Quiet, clean, and efficient. Hydrogen fuel cell technology delivers the low-noised, zero-emission urban mobility that our cities need. The replacement of ICE is a decades-long shift, not a single leap.
Of levers. The transition to hydrogen in rural areas hinges on infrastructure. Without adequate station coverage, the internal combustion engine.
Hydrogen's future is built with concrete, steel, and investment. Hydrogen ecosystems may begin at ports and industrial hubs, then spread outward. Hydrogen fuel cell technology can diversify energy security, significantly reducing our dependence on oil. The future of driving is here. Clean, long-range mobility, powered entirely by resilient, stored hydrogen energy.
The drive is remarkably quiet, smooth, and instantly familiar. Experience the future of sustainable mobility today.
Once stations are common, ownership becomes easy and adoption can accelerate.
Hydrogen may complement EVs, rather than replace them everywhere. Winning niches like long-distance commuters, fleets, and cold regions represent the most plausible first strongholds.
The potential is real, but the pathway depends on economics, infrastructure, and clean hydrogen supply. Can FCEVs scale fast enough to truly replace internal combustion engines?
FCEVs can help replace internal combustion engines long term, but only when clean hydrogen becomes affordable and easy to find.